So I would say exercise similar to problem number 27 is good to do before the midterm exam. So what I'm going to do is graph this function. So it's again section 3.2, exercise 27. And this problem wants us to look at the function which is cubic. The largest power is 3 here, so let's call it as cubic. X to the power of 3 plus 3x squared and plus 1. And this function, I need to find two derivatives. First derivative, f prime of x, and then take derivative of that and find the second one. And then I'm going to graph that function. So first derivative, 3 power is multiplied by x to the power of 1 less, x squared. Now, for the x squared, derivative will be 2x, so 2 times 3 is 6, and there is x, and number 1 disappears. So this is what I'm going to have to set equal to 0. So whenever we get derivative, we always set it equal to 0, so we can find special points that we're going to use to graph our function. Those are so-called zeros of derivatives, or numbers that make that derivative equal to 0. So we solve equation when product of two factors is 0, it means that each of them could be 0, and this gives me two of those special numbers, two solutions. Then I take that first derivative and differentiate again. So I find the second derivative f double prime here, and this will be 3 times 2, which is 6x, plus derivative of 6x is just 6. And again, the same exact procedure. I set this equal to 0 and solve this equation by, I don't want to factor 6 out, I could just divide by 6 everything. So we got x plus 1 is equal to 0, which means that x is equal to negative number 1. So I found 3 special numbers that I need to plug into my original function f of x. So I'm going to copy it once again. Now, how you solve these equations is up to you. I know people have different ways of finding x, but whichever way you used doesn't matter because they all give you the same exact values of x. So now I'm going to need to substitute my special numbers. So first of them will be 0 into this function. The second will be -2, and the third will be -1. So that's what I'm gonna ask you also to do on the midterm exam. That's why I would say this is a very important exercise, very similar to what you're gonna get on the midterm. That's why I highly recommend you over weekend redo this same exact problem. Just get a piece of paper, and I'm recording this lecture, so you could just take that recording that I will, as usual, email pretty soon after class, so you can use it. And I guess that practice could be also sent to me as your homework. So I guess that would be a good exercise to do. So after I be done with this problem, I will, of course, discuss the other problems for the midterm. So it looks like the first is when x equal to 0, we get 1. So I got a point here with coordinates 0 and 1. So I can right away make a picture of it. it's going to be a point on the y-axis someplace up here, 0, 1. Next, we'll get -8 here, and then 3 times 4 is 12, added with 1, so that'd be 5, I guess. So point with coordinates -2 and 5, someplace approximately up here. And finally, here we have a -1. 3 times, actually, I should be careful, that's -1, right? We use -1. So 3 times 1 is just 3, and plus another 1, so we get a 3. So another point with coordinates -1 and +3, somewhere, say, in between of these. So I've got 3 points that we need to utilize to graph our cubic function, the function that has x cubed in it. And what I have to know is that one end of this function is pointing up and the other end is pointing down. So how can I make a picture at this stage? Well, turns out I have to utilize like parabola approximation that will be going upwards. And then after that so-called inflection point, the other piece will be going downwards. And I guess I clearly mark these points, such as the first coordinates 0, 1, inflection point where the concave up changes with concave down, they say. So parabola opening upwards changes with one that opening downwards is -1 and +3. And finally, the last point with coordinates -2 and +5. So this exercise, very, very similar to it, will be on our coming midterm exam. The midterm exam will be on Monday, next week Monday, so I can write this down. Next Monday is a midterm. And it will have a couple of problems. And one of them will be very similar to this exercise I just worked out. So another exercise I sent by email, so I'd like to do a couple of problems that utilize limit approach now. So if you check out your email that I sent to you, I think 2 days ago, you can find that email with the attachment that's called midterm practice. So I'd like to do this exercise for you and show you some specific that I added to the midterm in order not to have every student in class exactly the same answer. So main reason that I ask you to use this student ID of yours is because I don't want you all to have same exact answer for take-home exam, because I will send it to you by email exactly the same way I sent you this midterm practice test. I hope you received it. If not, let me know. I will send it again. So I made up an example of a student ID, and I just put numbers like 1, 2, 3, 4, 5, 6. So it happened to be 6 as a last digit. So if your last digit is 6, what you need to do is replace letter B with a 6 here and here. And then you're gonna end up solving the limit when x still approaches to number -5. But instead of B, you should have number 6. So just replace b with a 6 and see what's gonna come out. Be x squared minus 2x and plus 6 divided by x minus 6. So now you should solve the limit, and since x approaches to -5, the way we work them out, those limits, was to put -5 instead of x into your entire fraction and see what will come out. So if that be some number, then great, this is your answer. If that's not going to be number, but something like a 0 over 0, then you need to do a little bit more work. So it looks like for this particular example, your denominator is going to be just -11, right? -5 minus 6. And numerator is like 25 and then plus 10 and plus 6, so it'll be 41. So that's it. That's your answer for this limit. So when you plug the number in, then, well, you just get something out. And if it's not undeterminate form, then you got the answer. So another exercise will ask you to solve some limits, and that'd be another problem on the test. And exercises will utilize these last digits of your student ID. So there is a digit before last that I call as A. So that'd be used in the problem number 2 that will be similar to the problem that I just done here. So I might ask like plus, say, A here. So you will put A, but that A is not going to make any difference when you're going to be taking those derivatives. So it's something that will be, I guess, kind of same for everyone. But again, the answers are not going to be identical. And that was my main idea why I wanted you to use those digits. Now, if this is going to be unclear on Monday, don't worry, I will be there. I will be on Zoom. So if you have any questions for me to answer, ask. Just log into Zoom at 2:45 as usual. And if something is unclear, you can always ask. I can clarify this for you. So no worry about that. In fact, I plan to email you this midterm exam sometime in the morning. So this way you will have a whole day to do it. Like I say, I can only do it after 2 I work. That's fine. You can do it later after 2, and you can do it till midnight or even till next morning, because Tuesday, the next day after the midterm, I will be grading it. And if I don't find your email, I will email you again and ask where is your midterm. So please check your email on Tuesday sometime in the morning, and by that time most likely I will also have your grade updated on Canvas. So let me do a couple of more problems with limits, so it'd be, I guess, a good practice. And yes, the homework is also going to be due on that same day. So let me do a couple of problems, and then we'll also talk a little bit about the homework. That's a great question. So let me finish up with math part. So I'm going to go to the textbook and find the sections that we covered so far. So I guess it's in the chapter 1 where we saw limits. It was section 5 and 6, right? So I click on section 1.5. I get this nice story of limits. So everything was nice when you have just plug numbers in and you produced the answer for the limit. but not that nice if you had answer in undetermined form. And that's why I want to say a couple of words. Let's say do problem number 17 here for you. So I'm going to get some room for that. So in section 1.5, and you can see the page that I'm looking at right now, it's 91. So I get a little bit carried away. I want to say that this is Monday, and that's a midterm, right? Anyways. So another problem is from section 1.5. So again, pages here on the right side, page 91. You can see the bunch of exercises with limits and problem like, for example, 17 is the one worth trying, because in this exercise number 17, when x approaches to number 1, then doing exact same step as replacing x with number 1 is not going to help, because you're going to end up with 1 squared minus 1 divided by 1 minus 1. So it is going to be undeterminate form, such as a 0 divided by 0. And that will be the problem. So you need to factor numerator and factor denominator. And usually factor that appears in denominator will be also a factor of your numerator, because we got 0 over 0, so that factor has to cancel. And the factoring of x squared minus 1 that I just produced on the top with x minus and x plus 1 will give me much nicer example with a limit when x approaches to 1 of just x plus 1. So when I replace my x with number 1, so I'll just end up with 1 and 1, and the answer will be 2. So whenever exercise is asking you to find a limit, first of all, you plug it in, you see if it comes out fine. And if not, well, then just try to get the result after you simplify. Another good exercise I'd like to solve could be something that deals with next group of problems. I believe I fully solved this entire set of exercises last time when I looked at that section, and you can always find this among the lectures. I just want to refresh your memories how we can get those lectures. In the same email, actually not in the same email, in the other email I have, let me see, here it is. So I posted on Canvas the recordings, the link to all of the lectures. Do you need to return the midterm practice? Well, that's for you. It's your practice. You decide. You want to return it in, you can turn it in. You don't want, it's up to you. So I'm not saying that you must turn in something. I'm trying to keep you, I guess, free from turning in as much as possible, but you still want to do midterm. So I cannot say, well, decide if you turn in midterm or not. But that one you should turn in. But for the midterm practice, is your choice. It's up to you. So you don't have to. But if you want, you can send it to me by email as well. So anyways, the link to the recordings, if I go to playlists, here will be our business calculus class. Let me mute that. So you can see all of the lectures that I posted here so far. I guess they mixed up a little bit. 6 and 7 went down but I'm sure you can figure that out. And I believe that in these lectures, in fact, if we return back to the question about homework, you should try a couple of problems from each lecture. A couple means two. Somebody asked me by email, is couple mean one? No, couple means two. So do two problems. If you want to do more, that's even better. But two problems should be good enough. And in those lectures, I did work out all of the problems related to the next group of exercises. So you can also work out a couple of those and make a picture and send me that by email. That will be called homework. So just do some practice and email me that practice, and that's all I need. And you can see that in these lectures, they work out these problems. You don't have to watch the whole thing. You can just scroll through this, and eventually you will get to the result, right? So I guess you don't have to listen to my explanation if that's annoying, but it might be helpful. That's why I think it's good that you have access to all of these little lectures. So I think I can share this link with you. It says ... I'm not sure if it's going to be working for some reason. So what you can do is go on Canvas. So let me try to get AVC Canvas. I'd be able to get it like that. Because they recently changed our system a little bit. So they like to do changes. So let's see if it's going to go like that. I want to share with you this link. I think I sent it already by email. I'm sure that most people saw it, but I'm just showing for just in case after you get the, not sure if that's coming out. Canvas, whatever. I think, I'm not sure if they have here. Here's the canvas, the first choice. It takes a little time. Maybe my computer is corrupted, or I should pay a little bit more for the internet. Canvas support, Canvas sign in. So here's the same sign in. Okay, so here's my sign in. Oh, they want me to get a passcode. Oh, that's unbelievable. Let me get that from my emails. Maybe I should stop sharing, should stop recording my emails, because who knows, my personal stuff I probably should not record. So just a sec. But anyways, I'm sure you know how to log into the Canvas program. So I'm gonna log in no time. They just decided to double check me. Well, they usually do it at the right moment. So it's nice that they're doing it. You should appreciate that, they say, Alex. Alex, appreciate it. It's not waste of your time. It gives you more security, right? So get this code here. They just nicely sent me some kind of code. Okay. So I hope now it's gonna log me in. So let me share the screen again. Okay. So after you logged into the Canvas, you go to our course. So I'm sure you know how to get to our course on Canvas. So it's 148. So I'm gonna go to the announcements. So I announced the, what did I announce? I didn't announce anything. Very odd. So let's go to the syllabus then. So I put this in the syllabus. So let's see. See, I have that Zoom link somewhere, and I thought I put it under announcements, but it's not there. So it's definitely not in the syllabus. So I guess I wasted your time. I'm very sorry that I did it. So what I do is go back and find where I send it to you. 148. So that's how you can locate emails from me. Just put 148. And of course, that should be in sent because I was sending it. 148. So let's see. Where is this? Lectures. That's a YouTube. Okay. So it's under YouTube lectures. So here's that link that I want to share with everyone. So again, these are the same exact lectures, but I can just put it now in the chat. So you can click on it and save it. Save the link, because otherwise, if you don't save it, you just saw how much time it took me to find it. It's annoying, right? So just click on that link, and once you have it, then just make sure that you use this star, right? Bookmark it. So that's how you can easily save it, because this way you will have access to all of the lectures, and this is great to have. So anyways, back to the story of homework. So I started to talk about homework, right? So we have again midterm on next Monday. Everything disappears because I just cleared my screen, but that's okay. So for the homework, you do a couple of problems from each section done on that in those lectures recorded on those videos. Again, if you need, you can always ask me for the link, or you could just search your student email. Just put 148 and you will find it right away. So, and as I said in those lectures, I done every single problem from the next group of exercises. So I can try one, let's say number 31, just to refresh your memories how we doing the problems when limit approaches to, let's say, negative infinity for a change. Not positive, but negative. Because here they say do one with positive infinity and do one with a negative infinity. Okay, so let's see what happens when we have negative infinity. Well, it turns out that this particular fraction has same powers for numerator and denominator, the largest powers. That's what I mean when I say the same. Turns out the other powers don't play any role here at all. So all I have to care about is just the so-called leading coefficients with those. So first is 1, second is 2. So that's going to be the limit when x was approaching to infinity. We did a lengthy process to justify that. We used to divide by the same powers. So I could just go through it if you want to actually more justifications. But as I said, it's all done in those lectures, so you could see it because I did exact same problems. So at that stage, you will end up with limit. And now you can simplify these little fractions everywhere. And that was the key idea, actually. So your numerator will have 1 minus 2 over x and plus 3 over x squared. So these little pieces, 2 over x and 3 over x squared, are going to disappear. And that's the main reason why we divide by x squared, by the same exact power, the largest power in both numerator and denominator. So what's going to happen, all of these guys are going to go to 0 because x goes to infinity. Same with that one and same with that one. And the key reason was that when you divide some fixed number by something very big, so let's say if I look at the first fraction, 2 over x. So I divide 2 by big, then it is small. And small means 0. Small, like 0.000001, so 1 millionth, 1 billionth. So it's nothing. It's 0. We ignore it. So we just left with 1 on the top and a 2 on the bottom. So that's our limit when something approaches to infinity. When something in denominator is big, then the fraction 1 over is small. So that's the key idea for these little exercises. So that's another thing I wanted to tell you. And finally, the last thing is when you have limit, when x approaches to some number with plus or minus, these are so-called left or right limits. It doesn't really matter. It's the same thing. So that's the idea. Just analogously to what we always do when we start to find limit, we just plug the number in. Like, I'll do one more exercise. I think that'd be enough. So exercise number 5, for example, here. So when you're looking at the next section, exercise 5, it's section 1.6. So you take a limit when x approaches to 4 on the right side. So it turns out you just plug in number 4 and you don't really need to worry about that plus or minus unless there is some kind of infinity, and that's what sometimes happens, but not too often. So 16 here, I multiply by 3, so I get a 48. I think it's better to put in a calculator so you get the answer correctly right away. So number 39 is the result. So notice I didn't really pay attention if that's 4 with a plus or 4 with a minus. And if you're curious what happens with infinities, I guess that'd be the lecture for you to look at. Again, you have weekend to look at those homework. So again, what is that we did for homework? I can look at the contents of the textbook and tell you exactly sections that we covered prior to the midterm. So we looked at chapters 1, 2, and 3, right? So for chapter 1, I guess main part was a limit, and I guess we didn't really care much about functional models, so just sections 1.1 through 1.3, which means 1, 1, 1, 2, 1, 3. So this dash means it's starting and ending and that. Then we also did 1, 5, and 1, 6. And then we moved to chapter 2, derivatives, and we also looked at a few sections there, actually first 4 sections only, so 2.1 through 2.4. And then we had a couple of sections in chapter 3, 3.1 and 3.2. So those are in the lectures, and you can just select, as I said, a couple of problems from each lecture. And again, send it to me by email whenever it's ready. So it'd be perfect if you send it on the day of the midterm next Monday as your homework. If not, well, I will accept it whenever you're done with it. So I recommend that you start doing it if you didn't yet. Start, and you have all of the lecture recordings in one place on YouTube. So I guess that's convenient, right? And wait for me to email you the midterm exam on Monday, so I will send it to everyone a little bit earlier. So I'm going to get this sent to everyone, just like I sent this practice midterm a while ago. So here's way to find 148, right? And I go for 148 only in midterm practice. So that's last email actually that you have from me. So you will get this attachment and you will get not one exercise, but there'll be a couple of parts for the limits and exercise number 2. So it shouldn't take you too long to do this, but I give you the full day, so as much time as you want. So I'm not gonna set any time limits. I want you to just do it without a hurry, do it right, and send me picture of your work. That's all we need for this class. So I guess that's all I wanted to talk about today. Any questions, please ask. If anything else. So again, it's good to do the practice. I understand that if you do homework and you want to do practice, you can send me practice as well. Why not? I mean, I'm not saying you don't have to, but I know some people say I don't want to do it. So that's why I keep the options open. But again, whatever you send me, just call it your homework and I will gladly accept it. Okay. So if there are no questions, then you should start doing homework. Or if you feel like you can start doing it tomorrow, but you should start. And that's why I'm gonna let you go today, no quiz. I'm gonna stop to record. If you don't have any other questions, then, well, then email me if you